to the Let's Talk Crypto podcast, where we discuss the latest Bitcoin, blockchain, and digital asset news.
Hi, everybody. Hope you're all well. Hope everybody in the community is enjoying the boom in prices. Bitcoin over 7,000, Ethereum approaching $200 again. It's hard to believe that we haven't been in these levels since early 2018. Are we back in the bull market? Who knows? Today, we've got a very interesting discussion on DAGs, directed acyclical graphs. I have no idea what they are, so I'll be asking most of the questions. I hope you find it informative. And with that, let's get going. Today, we join with Suyash and Slava. What is a DAG and what does it stand for?
So DAG stands for directed acyclic graph, and in graph theory, graph is a series of vertices which are connected to each other, and so the term for the connection is edges. The way I picture DAGs is like a mountain range, which has different peaks, and there are optimal ways to get from one top of the mountain to another top of the mountain. And so the other part of the definition is that they're acyclic. And that means is that if you start at one point, one edge, you cannot make a circle and you cannot end up at the same point. So you have to have a direction with acyclic graphs.
So does acyclic mean you never end up back at the starting point?
You never end up back at the starting point, exactly.
Okay, so the vectors are always away from the starting point. Okay, and that's what DAG stands for. That gives us a brief outline. Is it something which was invented for cryptocurrencies? Did it predate it? Is it a new thing on the block?
I believe no. The concept has been outlined a while back, before the blockchain was born. So, a typical use case is topography and solving different algorithmic tasks. But it has been used, it is currently used in several blockchain, decentralized ledger, let's call it this way, projects. And one of those projects is Iot, which I believe was the first project to utilize technology. They call it Tangle. And so Tangle, what Tangle is a special kind of directed acyclic graph, which is using the connections to transmit transactions.
Okay, let's just have the main points of difference between what a DAG is and a blockchain.
I think that it's very important to point out that directed acyclic graphs and blockchains are two different technologies. There are some things that are common in both technologies, but they are fundamentally different in the sense that a blockchain is based on a consensus algorithm and its distributed nature is very prominent. However, for a directed acyclic graph, that is not the case. It doesn't have a consensus algorithm per se. So let's say its distributed nature is often disputed. So this gives a basic idea of how these two technologies are, let's say, fundamentally different.
Okay, when you say they're fundamentally different, what is in place or what gives consensus or replaces consensus on a DAG?
Actually, I would say that a DAG is quite centralized when we compare it to a traditional blockchain like Bitcoin or Ethereum. Why? Because the way a DAG works is that it's very scalable. It's a very scalable model in the sense that you can add transactions very quickly. But the problem is that it's very difficult to authenticate these transactions to make sure that these transactions are correct without going through a central authority. I would take the example of Iot. There's something called a coordinator node in Iot. For example, the role of the coordinator node is to check that transactions are correct. Okay, and the coordinator nodes are controlled by the Iot Foundation. So this means that the coordinator node control is centralized by the Iot Foundation. It's not necessarily a bad thing, but when you see the grand scheme of things, it just means that it's quite centralized compared to a traditional blockchain.
Okay, so in place of having the consensus algorithm, which is sort of set in stone within a blockchain, or at least the Bitcoin blockchain, you have a entity which you have special nodes that actually validate transactions. Is that correct?
Coordinated nodes, correct.
Coordinated nodes, thank you. So is that a feature which is prevalent in all DAGs, or is that just IOTA?
I can speak for IOTA and the reasons why there's a coordinator. Before we jump into the coordinator, let's outline several other differences between a IOTA, which is utilizing DAGs, and something like Bitcoin blockchain, which is using a chain of blocks to transmit transactions. One of the main differences as IOTA is built is that it does not have, unlike Bitcoin blockchain, it does not have any transaction fees. So as we know, as we spoke in early issues of the podcast, transactions is a necessary reward for miners to find new blocks, to mine new blocks, and add these transactions to pending transactions to the blocks to propagate the chain forward. So when we're talking about IOTA, we have to understand that all of the IOTAs were created at the Genesis transaction. I can't remember the exact number of IOTAs there is, but all of the IOTAs were distributed to participants, community, and investors at the first transaction. Now, that means that because the technology, which is the underlying technology behind IOTA is different, it does not have to have miners per se to transmit transactions. What happens because of that, because there is no proof of work, as is with Bitcoin, you do not have to wait a long time to send transaction. The way transactions work with IOTA is that if you send a transaction, to be able to send a transaction, you have to validate two other transactions. So in other words, if I would like to send you IOTA, I don't have to pay any commission fee, but in order to do that, my node has to validate two other transactions which are pending. And so what it does is that the multiple nodes which operate in the network, and all of them have a different rating. In a sense, it's like a popularity rating. And that rating is being created by the amount of transactions you validate. So the more transactions you validate, the more trustworthy your node is. And therefore, we can speak about, just like with Bitcoin blockchain, we can speak about probability of correctness of a transaction, because both Bitcoin blockchain and IOTA are decentralized ledger technologies. Yes, Suyash mentioned that there is a coordinator. I'm gonna come back to it a little bit later. But just like with Bitcoin blockchain, there is a probability of a transaction being accurate if it is validated by a number of nodes. A similar thing applies to IOTA. So if my transaction was validated by a very trustworthy node, therefore most likely it is the accurate transaction. The probability of it being accurate is increasing. Now, the coordinator is currently in place, and this is one of the main points of contention criticism when it comes to IOTA. IOTA would argue is that they're working to get rid of the coordinator through something they call coordicide. It's the process of basically removing the coordinator. But currently, in order to avoid any hard forks and any double spending that could potentially happen, they have to have that mechanism in place. What it does is basically takes a snapshot of the system to make the truth authentic every several minutes, and then it transmits that signal to the rest of the network. And that is the version of truth that has to be accepted by everyone. As the network grows and as the utility of IOTA network increases, there's going to be less need for the coordinator, and therefore it will be removed. But as Suyash mentioned, currently IOTA has that mechanism in place which centralizes the system. And as I mentioned, this is one of the points of criticism when it comes to IOTA.
So just so I understand this correctly, there are no blocks. The transactions are joined together, like blocks in a blockchain are joined together, but it's actually transactions which are linked together. Because for my transaction to be confirmed, I have to confirm two before me. So in a sense, I'm linked to them. My fate is linked to that action. Is it fair to imagine like a web of transactions taking place?
I was just about to put forward this metaphor. It's similar to a web where intersections between different threads create nodes. And so the node can have different effects. It can have different authorities. Some nodes may be stronger. Some intersections might be stronger, and they're called vertices. Some intersections might be weaker. And so in a sense, when you transmit a transaction, you can actually randomly select a node that you would like you to connect to. So there is no one chain. There could be multiple different directions that the transaction takes place to get from sender to receiver.
And something that I would like to add is that DAGs such as Iot sometimes use some kind of proof of work. For example, Slava mentioned that to be able to add a new transaction or a new node to a directed acyclic graph, you need to validate some previous transactions. And this is actually a proof of work mechanism.
Okay. So in other words, your effort is noted by validating previous transactions. I got that. Okay.
Correct. And when we were talking about proof of work, you're also talking about the hashing power in the network. So one of the main reasons a coordinated node is present in a DAG, or more specifically in Iota, is to ensure that if an attacker controls the majority of the hashing power in the network, they still have the ability to make sure that the transactions are correct through the use of the coordinated nodes.
So I presume, Slava, when you say that when the network gets big enough, there won't be the need for the coordinator node anymore, it's because it will decrease the probability that an attacker will be able to hold enough nodes or enough hash power to be able to pull off the attack that Suyash just mentioned.
Yes.
Okay, that makes sense. And much in the same way as with the Bitcoin network, the higher the hash rate goes, the more miners that join, the more pools, the harder it is for an individual or a group of actors to pull off an attack which would reorg the blockchain, because they need a substantial amount of resources and power to be able to overpower to get above, say, 51%. That brings me to a question. In terms of security, the Bitcoin blockchain, an attack vector would be a 51% attack where you could hold a majority of the hash power and would be able to reorganize the blockchain, or perhaps even change consensus, split or fork the network. Is there such a thing as the 51% attack on the Iota or a DAG?
Hypothetically, yes. So if you have enough power, and this is the reason why coordinator is currently in place, you can fake the transactions by routing them through your own nodes. The other point which currently exists, the vulnerability that currently exists, comes from existence of the coordinator. So since it is centralized, can potentially allow the foundation to choose which transactions to send or to receive, so they can select the version of truth. The other thing is that Iota Foundation can potentially freeze funds. And that happens when coordinator would ignore some transactions that were spent by users. There's a number of different attacks. It's slightly different in terms of when we're talking about hashing power. Iota is built for IoT things, which generally do not have a high computational output power. And therefore, the number of attacks and vector of attacks is slightly different comparing to traditional blockchains.
When you mention incentive things and small devices with low power, what is the typical sort of use case of Iota? Will it be the next Bitcoin 2.0? Is it money? Is it programmable? Is it smart contracts? What will the use case be?
I don't believe they currently implemented smart contracts, but they definitely have that in place in the roadmap. So when we're talking about IoT, one of the potential use cases is smart cities or smart devices. So for example, you can have, if you're a farmer, and you can have a lot of small sensors that test quality of the soil or humidity, and the sensors would have to communicate. The sensors would have to communicate the quality of the soil, the level of humidity, And the conditions are such that a typical blockchain, for example, Bitcoin blockchain, would not be suitable for this kind of task. And the reason being is that the transaction fees are really high. However, with IOTA, as I mentioned earlier, it's a very scalable solution, and there's no transaction fees because there's no miners. The number of data that could be transferred is much higher comparing to traditional blockchain in a decentralized manner.
I sort of follow you, but I get lost a little bit. So let's imagine that we've got sensors for the farmer, with the story that you mentioned, and they're measuring perhaps humidity, moisture, temperature, and some other variables. Where does the need for a unit of value come in these IoT sort of sensors that are farmers' land?
I understood the question. So basically, you're asking what is the value of the use case that I just described. So for example, you can look at the conditions of soil and predict the harvest. If you have a centralized system where all the data from devices is being transmitted to a centralized server, that means that this data could be faked. However, if it is a decentralized system like IOTA is, it is an open ledger in the sense that every node can have portion of the data that is being sent through, so you can kind of audit the system to make sure that the data is valid. Therefore, you can be certain that the data is more accurate and it's hard to fake, and therefore you can predict the harvest more accurately.
Could you give me another completely different example just to make it crystal clear?
I would add something like autonomous vehicles. Let's take a broader picture here. When you see the emergence of new technologies and different advancements in terms of technologies. Previously, we had the introduction of IPv6 with the aim of catering for the increase in number of IoT devices. And then we have IoT devices and maybe in the future we will have 5G. So all these technologies, what they are catering for, they're catering for more IoT devices, more devices that are going to be connected to the internet. And when we are talking about connection to the internet, we are talking about transmitting data. And DAGs, for example, IOTA is very suitable for these kinds of applications, for these kinds of use cases where a lot of data is being generated. One of the examples that I usually think about is the use of autonomous cars. Let's take the example of Uber, which is heavily investing in autonomous cars, and this can be a very fitting use case where these cars the information which is generated from these cars can be stored and managed via directed acyclic graphs. And since this technology, DAGs, are suited for huge volume of data, and these applications like Uber can be fittingly integrated with IOTA or any other DAG.
Are you saying that the actual data that's generated with these applications, in other words, the autonomous car is driving, its location, its the conditions of what it's doing, the task it's doing, the current cost, everything is all going to be recorded? Is that what you mean?
Yeah, definitely. It could be like a certain use case involving all this information would be stored in a DAG and used to calculate fees and used for payments in terms of crypto and things like that.
I'm still trying to wrap my mind around it. Forgive me. It's not a case of, for example, I remember somebody telling me the example of an autonomous car using Ethereum to manage its own finances. So the car, for example, it's autonomous, would run its own business. It would have its own DAO, and it would at night drive to its station. It would pay for petrol wirelessly, fuel with Ethereum, smart contract, and it would get refueled by a robotic pump, for example, the next morning at a certain time. The car would pay for that. Then the next morning it would leave at a certain time and go pick up passengers, like Uber, for example, and it could sense when the rubber was running out. So it would drive itself to a place to get its tires fixed. It would settle that. And all these sort of things would be recorded on the blockchain, and the transactions, it would settle monetary values that it owes. It would run its own accounting. Do you see what I mean? So that's sort of like a sort of monetary sort of use case mixed with smart contracts and things of Ethereum. Now, where would IOTA come in there, as you're saying, is it would be more in terms of recording the data. What I don't understand is what's happening with the IOTA units. So if I buy 100 IOTA units, what's happening in this whole equation here? Is it replacing from a transactional point of view and data, or?
Well, it really depends on the application of the technology. So in the example that you've mentioned, Ethereum blockchain can do all of those things. However, the difference is that the throughput of Ethereum is comparably smaller, a lot smaller than the one of IOTA. Let's imagine a use case where you would like to rent out your car, for example, Tesla, for the time that you're spending at work. So in a sense, IOTA or any other cryptocurrency could become a unit of account. So you can pay to rent out a Tesla, someone's Tesla for several hours and pay a certain amount of IOTA. Now, the difference is that you can probably do the same thing with other cryptocurrencies or even with a centralized system. However, IOTA's throughput is much higher. So the precision of the price, the cost, how much it's going to cost you to rent the car could be much more accurate because IOTA can send additional data such as speed to the network, and that could help to calculate the price for the service. Wes, another example or another competitor to IOTA in a sense is a Lightning Network, where you can transmit Bitcoins at a faster rate, and you can do it at a smaller number of units without encountering the transaction fee. So, for example, you can pay for Netflix or watch YouTube and pay only for the amount of time that you watched. So a similar use case could be applied in terms of IOTA. So instead of using a Lightning Network to pay for per minute of Netflix you watch, you can use IOTA to do the same thing.
That makes a lot of sense. So, I mean, that being said, could you have a DAG as a second layer solution, not the Lightning Network, but as a second layer solution on top of Bitcoin?
When I was in one of the meetups, technical meetups about blockchain, I can't remember the name of the project, but they have tried to incorporate blockchain and DAGs in the same system. I don't think it was released, and I've asked a number of critical questions to the CTO, and he really wasn't able to answer them. I believe he recently joined the team. So I'm not aware of such system, but I definitely know that attempts are or have been made to do that.
Okay, no, because it sounds, I mean, the way you described it sounds like they would have very similar use cases. Fast transactions, low to no cost, also sort of distributing the consensus. Not so much the consensus, distributing sort of the validation almost. Because on the Lightning Network, you're sort of doing hops between people and not settling back to the blockchain. For every transaction, you're doing it, when a channel is closed or at a much later stage. Much in the same way, you've got this validating node, or this, what did you call it? The special node that IOTA has. Yeah, the coordinator. And they almost fill the role of the consensus that you have on the blockchain. So, there's a lot of sort of similarities in that, just different ways of doing things, I suppose, a new, different take on things.
Here's another example that I could provide. Maybe it's not a perfect case scenario, but it's coming from a personal experience, so I'd like to share it. About 3 years ago, I worked on a project, built a time and attendance solution for a uranium extractor in one of the countries. And what it was based on is something called BLE, Bluetooth Low Energy devices. They're very small. You get, it's like a quarter of a cell phone kind of transmitter that is connecting to Bluetooth of your phone. And so what we were able to do is we could map the floor, and then we would place these devices at a certain range from each other, and it could create a real-time navigation system inside of the office, which is not possible to do with GPS system tracking because the signal will get lost. So imagine and that company has a huge office. It's a massive tower. Imagine a visitor would come to their office, download the app or have the app, and he would get an automatic invite to select the floor or the person that he's trying to visit. He would then see specific directions where he has to go, and he would be able to see his location inside of the phone in the office. And the voice would tell him, turn left and go to the elevator, then move to the second floor, etc. But that same system could be used for employees. We use them for, it's a time and attendance solution. So we know when the person was on the floor in the specific room, or if the person has left to another floor or has left the office at all. And that information would be accumulated in the system and analyzed according to attendance rules, and then transferred into the payment reports for the accountant. Now, the way the technology works is that this Bluetooth low energy emitters, they're very low energy. They literally have one battery, and the battery lasts for 30 to 60 days. So in a nutshell, like, you cannot attach a blockchain or Bitcoin blockchain to these devices. Why? Because they're literally run on batteries. And if you utilize IOTA to do that, that's more possible, because the amount of hashing power that is required to propagate the transactions is minimal. And then hypothetically, and this is a hypothetical example, the time and attendance solution, a centralized server, can calculate the amount of time that you spend at work, and depending on rules and conditions, you can get paid out automatically with IOTA based on your availability at workplace.
The use cases are much different in that sense, that the traditional blockchain would be used for more, how would I say, infrequent type of transactions or exchanges, whether it's exchange of data or exchanges of value. Whereas IOTA seems to be for much more high frequency, repetitive, in some cases repetitive, but much more high frequency transfers of less value. It's not do or die transactions, but many smaller ones that are continuously streaming.
Mm-hmm.
And I think it lends itself more to automation. Whereas although Ethereum sort of wants to go that way, in its current iteration, as you say, it would be much more difficult. Not only confirmation times and things like that, but throughput, but also I think storage of data and the growing size of the blockchain. From what I understand, and please correct me if I'm wrong, the DAG sort of setup will have less footprint in terms of data storage than the blockchain. So, I mean, the size of the Ethereum blockchain is many hundreds of gigabytes now. What is the situation with IOTA, for example?
That is true. As I understand it, your node on IOTA does not have to maintain the whole complete history of transactions. What it has to do is to maintain the history of transactions that you transmitted. And because there are many different paths a transaction can take, you don't have to maintain the whole ledger. And therefore, the cost of maintaining the system is comparably lower. Moreover, there are wallets in place that you don't have to have you don't have to run the node, but you can also, nevertheless, you can still send and receive transactions without maintaining the history of the blockchain or DAG in our case.
Is it a big concern, the centralization as it currently stands, with having that special node that replaces sort of consensus and makes sure that everybody is playing by the rules?
I don't think so. The use of the coordinator node is very specific, but it is very useful at the start of the network, because at that stage the network is very small and it's very easy to attack a small network. However, as the network matures and becomes larger, the use of the coordinator node, for example, will be lesser. And actually, based on what IOTA is trying to do, they are trying to phase out the coordinator node, and in different steps. Like for now, they have already launched an open source version of the coordinator node, so everyone can see how it works and what it does to the whole network. And they do plan to completely phase out this specific feature in the future. So the whole idea is that at the start it's necessary, But hopefully, in the future, when the network will become larger and more stable and robust, it will be phased out.
It's a necessary evil in the beginning, but as the network grows and matures, it gets phased out. That also makes me think that the more transactions that occur on the IOTA DAG, it likely increases the speed or the throughput because you have more nodes validating. For your transaction to get validated, you are validating two before you, or at least two before you. And I presume that for you to be, when you get validated by nodes who are in front of you. So is it fair to say that it will go faster the more transactions there are?
Absolutely. And that's one of the very interesting features of DAGs. Like the more transactions there are, the faster the network will become and the more scalable it will become. And that's what is very, very interesting in use cases where we have a lot of low power devices sending a lot of data, as Slava mentioned earlier.
Okay, so it's not like with traditional blockchains, the more users and the more transactions, or the more transactions that are going through, you can reach a sort of upper ceiling, and then you have to wait for confirmation times, and the transactions aren't fitting into the blocks, and the fees go up. This is quite the opposite. The more there is, the healthier the system is, and actually it improves. The speed gets better, and the security gets better too, I presume.
That is true. And I think it is important to mention that IOTA, like many other similar projects, blockchain projects, struggle to find, to make its way into the real world in a sense. And just like Bitcoin blockchain, which currently has uncertain status in many jurisdictions, IOTA faces a slightly different set of challenges. So just like in the example that I provided earlier with Bluetooth low energy devices, there are two software development kits, one for Android and one for Apple, for iOS operating system. And they're very similar, but they have subtle differences. So the way I see it, in order to get connected to the world of IoT for IOTA, it will have to establish a standard kind of protocol SDK for data transmission, because large players really like to rebrand the technology and change it slightly to make sure that it's their brand. I've seen that happen with biometric devices and iris scanners. There's a number of companies that produce them, and all of them, even though the hardware is the same, the software layer on top of the hardware would have different protocols to operate. And so if we're thinking about IOTA as a kind of like centralized data / value transmitter for the world of IoT, it's a little bit challenging because the producers and manufacturers and distributors of hardware technology, they have different or slightly different set of protocols in place. Therefore, it's a little bit challenging to find the right set of keys for each manufacturer.
The only sort of gray area for me is there must be some sort of shared protocol or method. Otherwise, how will all these devices talk to each other and utilize IOTA if they are working off different protocols?
In my experience, so I worked with biometric devices. It's basically when you press your finger, and if your finger is accurate. And this is like 5, 6 years ago, before all the smartphones had the sensors, fingerprint sensor. You basically put your finger on the device, and if your finger is accurate, it's correct, it's your finger, the door would unlock and you can enter the room. And we've had to build middleware because we worked with different devices, and we installed them to different types of companies. And so the different devices use different technology, different protocols to transmit data. We had to build a middleware which standardizes that process. It was extremely challenging because even within the same manufacturer, different models of the biometric device would have different types of SDKs. Different protocols for transmitting data. So it was a big challenge for a relatively small technology company. And so what I see with IOTA is what I see IOTA is doing They're trying to they're partnering with manufacturers in Germany. Germany is really good for IoT, and the government supports Internet of Things in Germany. And by partnering with large manufacturers, they can therefore create and establish or change the standards for data transmission in the IoT world.
We've spoken about use cases. We've spoken about the differences between a DAG and a blockchain. Have we completely covered that, the differences between a DAG and a blockchain? We covered the fact that blockchains obviously have blocks and the transactions on side. The DAGs the transactions are actually linked directly. The blockchains, proof of work blockchains have miners. The DAG, they validate each other's nodes, each other's transactions. The one in front validates two behind. What other differences is there anything else that we haven't covered in terms of the differences between them?
I think, there is another difference between IOTA, which is DAG-based, and blockchain, and it stems from the applications, the use cases. Obviously, one of them is a financial use case because just like Bitcoin has a value, IOTA has, monetary value as well. But when we're looking at developing countries, developing regions, the transaction fees for using Bitcoin can be up to, correct me if I'm wrong, $10, $15 per transaction during peak hours, if I remember correctly. And that's just like you mentioned, the network can get congested. Definitely something like Lightning Network can address that in the future, and maybe even right now we see some applications being developed using Lightning Network. However, IOTA has solved to a certain extent that issue. And if you're in a developing region, a transaction fee of $5, $10 is a lot of money. And if you can transmit value using IOTA and pay zero for that.
Yes, no, that will open up a whole bunch of other use cases, which would be overlapping use cases, I presume, with the Lightning Network and whatever other layer 2 solutions Bitcoin eventually comes up with. Although the transaction fees aren't that high at the moment with batching and the new SegWit addresses format. So even though we are at all-time highs or very close to all-time highs in terms of transactions on the Bitcoin blockchain, the fees have not gone up. They've stayed very low, and you can get things through now for less than $1. But still, the same applies, whether it's $1 or 10. The low cost, high frequency throughput is much easier when the transaction fees are zero, of course, or close to zero, or negligible.
A very interesting thing about IOTA, if you look at CoinMarketCap, which is a website which outlines the majority of cryptocurrencies and shows their value at a given moment, you'll see that in parentheses next to IOTA, there is something which is spelled MIOTA. And so the cost for MIOTA, the value of MIOTA is currently at 0.29 cents. And what it means is that actually 1 million of IOTAs cost 0.29 cents. Because the price per one IOTA would be so small, it makes sense to denominate the currency in millions.
Oh, wow. So I'm actually looking at it right now, and it says 2779530 283 MIOTA. So that is the circulating supply of IOTA, and you're saying we must add 6 zeros to the back of that.
I believe so.
Wow. I don't even know what that number would be. That's incredible. So yeah, okay, there's an abundance of the units available in IOTA. And correct me if I'm wrong, they've all already in existence. They don't get mined. There's no reward paid. They all exist. Where are they all right now?
There is a Genesis transaction, and as you can see from CoinMarketCap, the max supply is equal to circulating supply. So what happened during the Genesis transactions, all of the currency was distributed to a community, investors, founding team. And that is necessary to support the network. The more decentralization you have in that case, the better it is. Just like you, Wes, mentioned earlier, the more users will be using that currency, the stronger the network will become, and the higher throughput will be achieved.
I presume that the centralized party, being the IOTA Foundation or company, is holding a majority of these IOTAs, and the rest has been distributed in a crowd sale?
It was a crowd sale before it was the term ICO was coined, I believe, they were very, very early on. And I don't remember, to be honest, what proportion the foundation has received, but I do remember they raised a very negligent amount of money at the beginning, which I would imagine is potentially one of the downfalls. Not having a lot of money to build potentially something new and potentially revolutionary that requires a lot of resources. So they were very early on, and I don't believe they received a lot of funds through the ICO. I think Tron is better marketed.
Yeah, that's true.
The founders of IOTA do not care to go on Twitter and just say whatever they think without being political, let me put it this way, and they get a lot of criticism for that.
In terms of it not storing all the data on the network, not needing to store as much data as a blockchain, are there snapshots taken every so many, I don't know, time frames? Or if I'm validating a transaction that happened before me, how is that value, in Bitcoin, you've got unspent outputs that you can always look at. How is that value tabulated within a wallet, for example? Like if I have an IOTA wallet and I'm not an IoT device, I'm a person, I've got a wallet. Where's my wallet getting that data from? It's not like Bitcoin where it can look at the blockchain and can look at the list of unspent outputs and match it with my private public key and address and say, okay, that's the balance. And anybody can go and check that address and say, okay, that's the balance. Is there some sort of similarity there? You've got a wallet, you've got a wallet address, and how is that sort of keep balances of all the different actors in the system?
So IOTA also has public-private key, which is generated from seed. That answers a portion of your question. Right there.
Do you guys think that it's unnecessarily overcomplicated as a system?
The advantages of the system are there, but I think they're yet to prove it. And whether it's overcomplicated or not, it just depends on whether they solve the use cases efficiently.
I'm just talking about the general public here. I mean, I suppose in a direct basis, IOTA's first sort of use case would be with IoT devices and things like that. And general adoption by actual users, people like you and me, is not really required. We don't really need to wrap our minds around IOTA as such for it to be used in IoT devices. Mm-hmm. Whereas, somebody who's transacting every day and wants to move on to Bitcoin kind of needs to handle it and, know how to send it and receive it and transact with it and needs probably a little bit of a basic understanding, not too deep of the ins and outs basically of what a blockchain is. And that's about it, so that they're able to go themselves and look at a block explorer and see that it's been confirmed, understand what those confirmations mean, like 1, 2, 3, 4, 5, 6 confirmations in terms of security level. And that's about it. But when you look at IOTA, perhaps the user, for them to get a certain level of adoption, a measurable start to success, just use in IoT devices where it's invisible and users don't even need to know that it's working in the background and it's transacting between devices and things like that. That is one of the big differences. Perhaps that's something which doesn't require the user to know so much about the technology. It's only if one starts actually transacting as a human that you kind of need to know in more detail how these things work and what the mechanisms are behind and how to send and receive and things like that.
Just like with other cryptocurrency projects, IOTA is reinventing itself and trying to find the optimal position, whether it's a consumer market or a B2B market, IoT market. If we look at Ethereum and the initial kind of message that Ethereum was proposing, the value that it was proposing is that it's going to be a decentralized computer, which is probably still true, but I think they went away from that messaging after Ethereum has become a platform for ICO and crowdfunding. Right now, potentially, one can argue that Ethereum is going to be a central place for decentralized apps, which is the next iteration of, next step after a lot of companies raised funds through ICO on Ethereum network. So just like Ethereum, I think IOTA is going through a number of stages. They're definitely pursuing the B2B sector, and therefore, Wes, as you were saying, it's not really relevant for end user to have a beautiful interface where everything is clear and it's working perfectly. If they can figure out how to start utilizing technology in the real sector with machines, with computers, with different gadgets, and create value there, it's gonna be very valuable kind of system, which does not require a very user-friendly interfaces for people for the consumer sector. If that does not happen, I still think if the network grows and you can transmit value without having to pay zero commission fees, and that could be beneficial for a lot of people in a lot of different parts of the world. But we do need to realize that in the consumer sector, there are alternatives such as Lightning Network are coming into play very soon. And just kind of like thinking about your earlier question, whether IOTA is unnecessarily complicated, I think it's fair to say yes, because from what I understand, not many exchanges support IOTA. And the reason why it's because it's a little bit more complicated to plug it into the exchange system and support. If you're an exchange, it's a little bit challenging to support IOTA. And so in that sense, yes, IOTA is slightly overcomplicated, and that potentially impedes the development of a project.
Yeah, I just think of it also in the sense, I agree 100% with what you're saying. It will impede the project if we don't get, developers interested. I mean, that's one of the things that Ethereum did do right, was get developers very interested in developing on their platform. But further to the overcomplication statement I made is one of the beauties of Bitcoin is to try and keep things simple and try and lessen features and things like that to reduce the attack vector. So I just wonder what sort of attack surface the IOTA DAG has or vulnerabilities that haven't been exploited yet, purely because it's not really worth anybody's while yet to attack, albeit it's worth hundreds of millions but it's not of the level, of Bitcoin or even Ethereum or anything like that. And I wonder if it becomes, worth hundreds of billions one day, whether it will be able to withstand the sort of types of attacks that the Bitcoin network can withstand, and if it can, obviously, then there'll be a value placed on that. But with complication, I just think that it also opens the door to perhaps more things that can go wrong, more attack vectors.
That is true. And one of the indicative factors for IOTA probably being overcomplicated and not delivering as much value as other alternatives right now in cryptocurrency industry is that I think at some point it was third by the market cap. So that happened last year. If I remember correctly, definitely was on a third or top 5 places among all the cryptos, and it definitely has lost ground since then.
Yes, no, I definitely remember it was over $1 billion in market cap when I first discovered it, because it just showed up suddenly in the top 10 on coin market cap. I think, as you said, maybe even top 5. And up to that point, I had never heard of it. And suddenly I saw this IOTA there, over $1 billion at one stage. I don't know how high it got. It probably got much higher than that. But when I first noticed it was over $1 billion, and then I started following it. Yeah, I mean, it has come down a bit. But, they all have at the moment.